Welcome to the Digital Amateur Television Experimenters Night. This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. You realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world. Also participate in the night by coming up to the Queen's Domain club rooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
Okay, this is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania, and I've got Steve, VK7OO, in the studio. Hello, Steve.
I've got my badge on.
You do? I love it. Excellent, excellent. You have a good day?
I've had a good day, yeah.
Excellent, excellent. All right, I'll just, so, in recognition of the deep history and culture of this island, I would like to acknowledge the Muanina people, the traditional owners of the land upon which we are presenting tonight, and we acknowledge and pay our respects to all Tasmanian Aboriginal communities, all of whom have survived invasion, dispossession, and continue to maintain their identity and culture. So that's our acknowledgement of country. Now, the reason I've got Steve in the studio was, on our Discord, our very active Discord channel.
It is very active.
It is very active. And there is some valuable information that gets posted there. There is some quite funny information that gets posted there as well. But on our Discord channel, Steve posted today the silent key notice.
Yes, from Tony Parks, whose call sign I can't remember.
It's KB5YIG.
YIG. And he's the inventor of the Softrock SDR. And not only the inventor, but he was also the manufacturer and distributor, and he did all this in order to get SDRs out there. That was his primary goal, was to make them as cheap as possible and as accessible as possible, easy to use, and they weren't flash.
No.
But they were a very affordable way to get started in SDR.
Here, I've just put on the screen. This is actually quite an old website. It was 2010 but that I came across, which was WB5RVZ's SDR page, and one of the key things is it's got all of the Softrock, the different types of Softrocks.
Yep.
So I built the Softrock 40. That was it. Was a little square board, square board, I think, from memory.
Yep.
Unfortunately, I couldn't find it. We found a couple.
We found a couple of unbuilt. I got some unbuilt kits,
and I've got one that's built, but I can't find the Softrock 40, and I can't find the IF one. But Steve actually has the IF combined. So if we go to document camera and transition to the document camera, ooh, bit of shine there. This was the IF Lite 2 combined, which is the kit.
One of the last ones they came out with.
Yeah, because it's the 2. I don't think mine was the 2. Mine would
the 2 was one of the last ones, yeah.
But this primarily was the I suppose it ended up being used.
It was intended, as a pan adapter.
As a pan adapter. So you put the IF frequency crystal of your rig into this, and you could then through an SDR software
something like HD SDR or whatever. Yeah.
You could then display an amount of your the frequency you were looking at as a continuous pan adapter. Yeah. So the reason I got this was people realised that you could put a 630 metre, put a crystal in it with at around the 630 metres, and actually use it as a 630 metre receiver. Yeah. For when we got 630 metres, so that was the IF Lite. Now, what was the other one? That's this one, isn't it?
The same one, yeah. You got the built version. That's the kit.
So this was the 6 metre, 4 metre, and 2 metre RX ensemble board. This was quite a bit bigger. So there was all of this, and there's more in the packet, and then the built version that's the built version there, and there is some ICs and the SI chips frequency generator on there, and that was driven through the USB port. So your SDR software was driven through the USB. There's a little microprocessor, 8-pin microprocessor, and then that frequency, there's a little optocoupler, and you'll notice if you flip it over, everything's isolated between the frequency generation and the rest of it.
Yeah, because the USB side of it's fairly noisy.
Yeah.
They tried to isolate it.
Didn't want birdies and all sorts of stuff on the... and so this is the 6, 4 and 2 metre ensemble receiver. And I did use this for a little while.
You'd build it for one frequency.
Yeah.
This is the key thing about Softrock. They were designed as one frequency. But despite the fact that it had a programmable SI chip in it, it was never meant to be frequency agile.
Yeah. You
would build it for the band that you were going to use it on, or a specific frequency.
And I think I built this for 2 metres. So yeah, and at the time, the only SDRs that were out there in the market that were affordable, they weren't
affordable. That's the thing.
Were HF SDRs.
Things like Hermes and stuff like that.
Correct. And I then went into HP SDRs and all sorts of things, and decided to spend. This convinced me that I needed to spend the money and get a better SDR and all of that sort of stuff.
Yeah, because that's basically a direct conversion quadrature receiver.
Correct, and it uses the SDR at some point in the chain needs to convert the audio to digital and digital to audio if you're transmitter receiver arrangements, and so it uses the sound card to do that A to D and D to A. Whereas this is a generation 1 SDR. The next generation, so generation 2, they actually put A to D and D to A chips in the SDR. And they
put preamps and other things.
Well and truly.
These were very basic, but they worked.
And they were cheap.
Yes, very cheap.
So yeah, that's.
And you had to build it yourself.
Oh no, well and truly, it came as a kit. There's the kit, and there's the built version. So yeah, it's there you go.
So Tony was doing that up until 15 odd years ago.
Well and truly. Well, that was because this YB5RVZ was the distribution channel, and he did a lot of the documentation.
And all the documentation.
Yeah. So and we're talking
that's 2010.
As of 2010. So
that's 15 years ago. So that's around about the time that Tony stepped away.
Yeah.
And he handed over the distribution of the kits. And prior to that, he was doing it in his own time, off his own bat, as a retired person, and basically charging people what it costs him to put the kits together.
Oh no, well and truly.
Yeah.
I'll just show this. I absolutely love this. This is sent to Steve, and you can see there's the Ronald Reagan and the Benjamin Franklin stamps on it, from Tony Parks, Springport, USA. I absolutely love it. That's so Vale Tony Parks.
Yeah.
I just bit of a sad loss.
But he made SDRs accessible to the masses,
Well and truly.
which was good.
And his inspiration, the little bit I read, his inspiration was actually the guy that started Flex,
Oh, okay.
Gerald Youngblood.
Mm-hmm.
And I don't remember his call sign, but Gerald Youngblood was the guy who started Flex Radio. I don't know whether he's still involved with Flex Radio, but he certainly started the Flex is going from strength to strength. Okay, Andy, or if we've got someone from the US online, I'm just having a bit of a look. And hello to Andy, to John, to Bronson, to Darren, David, and Dan. Hello, and stick your comments. And there's a couple of questions in there for the those on the chat. So good stuff. But his inspiration, and he had a lifelong friendship with Gerald, and so and I think he sort of saw that Flex went in the almost
professional market.
Almost professional market,
Yeah.
and he then went down the making it more accessible.
Make it as cheap as possible.
Well, truly,
And still good enough performance to be worthwhile.
And you could plug that in and still use it today. Well and true. If I fix that toroid. I noticed there was a broken toroid on here, so I've put it into a box or done something or dropped something on it. But anyway, and fantastic. One of the things about it was there was fantastic documentation.
Build documents. Yeah.
The build documents you had. The bill of parts and a picture, an actual picture of the part, and what you had to do, the part of the PCB that you had to do it on, and that was there was huge numbers of pages. I know it was 40 or 50 pages to use the ensemble to build the ensemble, but I built the ensemble and guess what? It worked first time. So yeah, fantastic documentation, which I assume is this guy here. So
the WB guy, yeah. He did all right.
But yeah, very sad news, and Vale Tony, just okay. Next up, we have some comments. Now, last week we had our electromagnetic radiation presentation on electromagnetic and EMR assessments. Got some great comments about it, and people have gone off and are doing their assessments, which is fantastic, and more importantly are documenting their assessments.
Oh, yes.
Which is the package that we put together for the assessment, for recording the assessment and then going through it. Please, if you come across issues with it, if you come across improvements, please let us know, because we'll incorporate that into future versions of it. But one of the things was, and one of the bits of extensive feedback that I actually got was from John Booz, who is JBE. I keep saying BJE, it's JBE. Now, John was the one who put together the package, the original package that we actually showed and went through and used. Now, John in his working life works in Telstra mobiles, and specifically in the EMR type assessment part of Telstra mobiles. So he has some fantastic experience. Now, he watched I think he watched the stream, but he also then rewatched that stream, and just made some comments which I thought were very pertinent. He sort of said, he watched the interactions that were going on during the night, and he made the observation that people seem to think of the worst case scenario, and not the actual case.
Mm-hmm.
So, and how the standard should then be applied in real life. So, things like they need to apply those real world factors to reduce the level from the worst case. So, and he gives some examples here, like the actual transmission line, actually doing the calculation around the transmission line, because in most cases the transmission line will have loss, and potentially that loss brings you back down to an acceptable level, or the may or may not bring you back to an acceptable level. The local or partial body exposure versus a whole body exposure. So that's, and this is very dependent on the types of antennas. I suppose a really obvious one is a highly directional antenna, a la dish.
Mm-hmm.
You obviously don't stand in front of the dish.
Definitely.
It's that sort of thing. The losses due to coax, filters, etc. So anything in that chain between the transmitter and the actual antenna. The directivity, which is what we just said, and the energy density of the mode. So the comparison between SSB and FM was one that was given. FM, there's constant power, no matter whether there's an
100%,
audio signal or not, versus SSB, which is the 20% that you put in there. So, and lots more. So he just made that observation about we tend to sort of jump to that worst case instead of pulling back and saying, well, hang on, what are the mitigating factors and what are the things that I haven't taken into account that I could take into account? One of the things he needs to explore is a little bit around energy distribution on a HF long wire or a dipole antenna.
Mm-hmm.
Very dipole, yes. HF would be dependent on HF long wire would be dependent on the frequency, because you've got nodes and anti-nodes along that piece of wire. So some interesting stuff around there. He talks about on cellular antennas with a 10 to 12 patch elements, all phased up to vertically. The energy at the first 1 to 2 meters out of the front, where the beam is formed from all 11 or 12 elements, versus if you go 200 or 300 millimeters away from it, the energy level's almost nothing.
Mm-hmm.
So and that's also to do with obviously the frequency. The flowchart tool. I just made the comment here. It'd be fantastic to be able to have an electronic version of it, and I've started a conversation with Phil around whether there's some scope to make it electronic. Like you literally, it asks you the question, you answer it, it then goes to the next, then, and you can key your way through that flowchart, and then at the end go, save as a PDF or print or whatever. So yeah. And he made the comment. He said he'd like to see all classes go into the EMR Safety Site Management Book. Yeah. So whether it's compliant, so it's a class 1 or it's a class 2, doesn't matter. Everything goes in there, so that anyone who's looking at it can then see, okay, you've gone through the process of the assessment for that particular antenna.
Made the assessment,
Well and truly. And this is the rationale that you've used to make that assessment. It makes the comment here, antenna system spreadsheet. So the spreadsheet has a location field on it. He's advocating that you should really be as descriptive as you can be about the location. So not just say it's on the roof or it's on a pole or whatever else. Actually say it's X amount of distance from this. It's lined up with this, etc., etc. So rather than just saying it's private or public or whatever the sort of short form is. He really liked the statement of compliance, so he's incorporating that into his. Okay, we've done that. Now, he made a comment, how to deal with the family in the backyard is a tricky question.
Yep.
And it is.
We're also thinking that in my case, my wife would be classified as general public.
Yeah, well and
Whereas
truly.
I'm not.
Yep.
So yeah, I would have to take that into consideration.
You're an aware user.
Yeah, whereas my wife definitely is not.
Yeah.
You know, and that would be the case for most families.
Yeah, yeah.
Kids especially. Yeah.
Well and truly. And yeah, actually, you're right. Because I was just thinking, Ruben's an amateur. He's a foundation amateur, so he's got some understanding. Helen, no. The next door neighbours, no.
My grandchildren definitely not.
Oh no, well and truly.
Yeah.
Think about how we manage other risks in the backyard. Was one of the comments that he actually made. Interestingly, pools have fences, but not really a warning sign.
Mm-hmm. Yeah.
Just a CPR sign. So yeah, is there a verbal warning? Is there all sorts of things? So now he did, and I put this in the description for the video. We were wondering during that session which of the ICNIRP standards, so they were the UK standards, whether it was the 2020 or the 1998 version, because you get both. It is the 2020 version that the ARPANSA standards, the current standards, which were 2021, I think, were released in 2021, were based on the 2020 standards. So it is that second diagram with the exclusion hazard zones on it that you need to that's the one you need to comply with. So yeah, and he goes on and makes a comment. He said he's been using Microsoft Copilot AI to do some thinking about some of the other scenarios and also the different modes. We were talking about the fact that FT8, FT4 and a few of the other modes came up with 42%, I think, for the transmission, which we sort of questioned. So, and he goes on and says he's pretty sure that the transmit time for FT8 and FT4 are actually probably incorrect. But he also makes the comment. He said AI is not always correct, so you need to question it. You need to double check it. You need to cross check it with something else. So yeah, that's the just made some great comments. And this is the guy that came up with the EMR Safety Site Management book that we used as part of that exercise. All those documents are available in the video description. So if you haven't had a look at that last week's EMR presentation, please do, and give it a try. And if you've got some feedback, send it back through to us, and we'll see what we can do.
Yeah, one thing I thought it was normal operating hours.
Yep. Okay.
Because most of us only operate at night.
Well and truly.
Yeah, so that would be something you'd consider.
Yep.
Yeah.
Oh no, well and truly. And note that in the management book. Normal operation or that sort of thing, or if you're running at 24, and like there is one antenna that I run 24/7, which it's on 30 meters right at the moment.
But that's receiving, isn't it?
No, it's transmitting and receiving.
Oh, it's transmitting.
It's so, but it's the ADX. So we're only talking a watt or two.
A couple of watts, and it's what, whisper?
It's whisper.
So it's only transmitting 2 minutes out of every 10. So it's never going to make the 6 minute requirement.
Well and truly.
Yeah.
And it's on a long wire, that's up. Oh, how high is it? 10 meters at one end and probably 4 meters at the other end. So
out of reach.
Oh, it's out of reach. It's well and truly out of reach. And we're only talking like 2 watts. So yeah.
It's class 1 anyway.
So yeah, and so you've got to think about it. But I need to include that in my assessment. That's the issue I've got with the assessment is I'm going to be constantly updating it because you're experimenting with different antennas all the time.
Yeah.
But okay.
It depends on who you are. I mean, if I put an antenna up, it's only ever meant to go up once.
Yeah. Okay. Okay.
I generally expect it to work first go, and
Yeah.
once it works, I'm leaving it there.
Yeah. Okay.
But other
Okay.
people I know will pull it down every other weekend and change the antenna and do this.
Oh.
Yeah. So it depends on the individual.
Correct. So, yeah, and I keep being asked to I keep being asked to clean up the backyard, and because nobody can get into the backyard, and I'm actually thinking that that's probably a good strategy.
I don't think that'll work at my place.
No. Anyway, I can probably only use that excuse for a limited period of time. But anyway, so now comments and FM Alive on 11 meters. Oh, that's Mark. Okay, so 11 meters is open. VK7CO watching. Okay, the other Mark. All classes have to do it in the UK. Andy's comment, well and truly, and exactly the same here, Andy. All classes have to have a knowledge of the EMR requirements in Australia, well and truly. So the only, I suppose the only exception to that is the foundation are automatically class 1, but taking on board what John said, even if you're class 1 and you're compliant at class 1, you really should be documenting it so that you can demonstrate that you understand the requirements and the standard, and that all of your transmission and antennas are compliant. So yeah, that's
I've got some homework to do then.
Oh,
Because I haven't done this yet.
no. Well, I've done it I've actually done it for the loops.
Yeah.
Because Martin 7GN asked me as to whether I had done any field strength measurements of my loops, and he also, which was fantastic, gave me the design out of, I think it was QST back in the 60s. I think it was a 60s design of a field strength meter using a ferrite rod. That I've got all the bits together in a bag ready to build, because I actually want to do some field strength testing of the mag loop.
So how do you calibrate a field strength meter?
Interesting question. I suppose the professional way would be to send it off to a lab and pay a lot of money to get them to calibrate it.
So let's have a practical method of calibrating your field strength meter.
But you could go back to first principles and have a known field strength.
Yep.
I don't know, across a range of frequencies that you can then calibrate to. And so it is, whatever it is, 100 millimeters away from this, it should read this. And get that calibrated. Yeah. And then everybody else can calibrate from that. So yeah, but interesting question. I have a field strength meter that I have sitting in the shack, which is uncalibrated, but it's just literally a meter with a diode and some tuned circuits in it that I can switch in and out. And I have it sitting there specifically for HF. It does go higher than HF though, for HF. And that's how I realised that there was actually on 40 metres quite a bit of RF in the shack.
Right.
And I sort of went, probably need to look at that. Because that means it's coming back down the coax, which it shouldn't be. Yep. And I actually, I bought and built up, Hayden referred to it in the V&A, Halibut Labs have a common mode test jig.
Yep.
That enables you to plug in the V&A, the Nano V&A, and in fact that might.
Didn't Lance make one of these?
Oh, he made a version of it.
Yeah.
Halibut Labs. The really nice thing about Halibut Labs is it's got all of the different coax connectors on it, on both sides, and it's got the open, the short, and the 50 ohm load for the Nano V&A built in. Yep. So you can actually plug it all in do the calibration with it plugged in, which is what you should be doing.
Yep.
And then test whether you've got common mode. And it's got a couple of switches so that you can switch to the outside of the coax or etc. So it's got all those switches built in. So it'd be good. Actually, I'll organise to do a session in the ATV night. So on it, because it's great little jig and really handy to have in the shack if you've got some RF creeping in from somewhere and you need to try and work it out. So
Okay, so the subject of a future night will be calibrating field strength meters.
yeah, maybe. I'll put that on the list.
Oh, yeah, come on.
But if you've got a source, if you've got a known good source,
somebody knows how to,
which I don't, I might have to ask
field
about
strength
that.
is the easiest thing in the world to measure, but you don't know what you're measuring.
I know, correct. And it's all about orientation in the field. So you have to understand how the field's actually emanating from whatever it's emanating from, and a few other things. So anyway, that's a future. Now, how are we going for time? Oh, okay. Now, have I got a deal for you? Now you can stick around, Steve, because I know you want to know what this is. If we go. Here we go. Now. Okay, I'll go past you. Now, what are we looking at? We're looking at, and I showed this a couple of weeks ago. This is...
it's really heavy.
It's heavy. I showed this a couple of weeks ago. This is a Ringer Dynamotor. And any of our Telstra / Telecom / PMG people out there will recognise this. In the old electromechanical exchanges, there used to be two of these. This is the small version. So this is out of a regional exchange. The one at Cygnet, for those people who know Tasmania, this is out of the Cygnet Exchange. There would have been two of these. One was a primary, one was a backup, and you could switch between them. But this is a dynamotor. A dynamotor is one voltage in and another voltage out. These are used in used to be used all over the place. That's now been replaced with electronics.
Yep.
In this particular case, it's 48 volts in, so all telco gear runs off 48 volts. 48 volts in one end. You get the label says 75 volts AC out the other end at 400 hertz.
Mm-hmm.
Now, you're getting about 90 volts because it's unloaded.
Yep.
So 90 volts at about 400 hertz, which, surprise, is what used to generate your dial tone. Your dial tone. Now, what I was going to do was demonstrate this. Now, I've got down underneath this I've got a 48 volt 10 amp power supply, which is actually an ex-Telstra one. I'm going to, I've connected the power supply and there's a bit of current being drawn, not very much. And you can notice this is now turning. So there's a shaft, major shaft here, runs at about 1000 RPM. It sits there, and these used to run 24/7. So everything had to be exactly right and very nicely machined. There is a shaft that comes out the top. There are a whole lot of, and actually, what I can do here, can you pass me that one? What I can do, I just put it to sleep. That's it. So, if I zoom in here, how far can I zoom in? There we are. Ooh, up. You can see that shaft turning. And there's a whole lot of cams on here that do different things. There's one here that's got 2 dips, and then there's one here that's got 50% on, 50% off. Then there's one here that's got about 2/3 off and one on. And then there's one that goes on and off even sooner, which is actually your engage signal.
Oh, okay.
And there's the equivalent over the other side. So there's a couple of other different combinations. And they go through, and there are relay contacts here that are clicking away on both sides here that are switching the variety of things that you need in an exchange.
Wafer switches.
Correct.
Yes.
Wafer switches.
They're not relays, they're wafer switches.
Sorry. Correct. Now, let me just zoom out a little bit here. Because what I've got down below, can I go a little, oh no, I can't. Because there's the container. Let me go up a bit here, and I will lift it up. What I've got here is a 800 series dial telephone, Decadic telephone. And I've got a few of those, and I've got it connected up, and I can connect up. Now I've got to be a little bit careful here because there's about 90 volts coming out of here. But if I connect this up,
oh, it's ringing.
The telephone is ringing. And if I lift it, it stops. Funnily enough, it stops.
Why is that more an American ring than an Australian ring?
I'm not quite sure. Just hold that thought. But what that's doing, so the ring, if we read the label,
In fact, that's inverted.
Yes,
The ring's inverted.
Because I haven't found the right cam.
Oh, okay.
I think it's that cam there, but it's actually, well, the one I've got that's coming out there is the other cam.
Uh-huh.
I'll find it. But so the ringing tone is 400 cycles per second at a 16 2/3 frequency.
Mm.
That's what the ringer is. Now, if I managed to go through and find all of these different tones after some trial and tribulation. So that's the ringing tone. Okay. So, when you dialed the number, you would then get this dial tone. Now I'm holding the receiver up against the microphone so you can hear it.
Not sure it's working.
So that was the ringing tone. So you knew it was ringing at the other end?
Yeah.
Now, the ringing tone, the dial tone. Okay, let me just connect this up so that I've got the dial tone. That's these two. Yes. That's the dial tone. Now, there is a fantastic site on YouTube. All it is recordings of different telephone signals.
Oh, okay.
That somebody has got together, and it talks about, this is going through a crossbar exchange through an STD connection to a this, to a that, and that's all the recording is. That's now the engaged tone is.
Has it got STD tones as well?
Oh, I don't know about that. Oh, that might be a bit on. Now, that's the engaged tone. If you're online, can you just let us know in the chat whether you can actually hear that coming through? I'll just do that again. But that's an engaged tone, and then what we've got. So the grey one. Let me not get zapped.
Yeah, apparently we can be heard.
Oh, fantastic.
Yep.
And then we've got the no line available tone.
It's very soft.
And I suspect that's probably hasn't been used in I don't know how long. But anyway, so that was they were the different tones.
You know when you got the no line available tone?
Yeah.
Any time on a weekend, like a Sunday, you try to dial any number starting with 0. Just no lines available.
No lines available because everyone was on there.
Everyone was talking to their relatives on the mainland or whatever, which meant you couldn't dial 000.
I love it. Anyway.
That is definitely the wrong way around. It should be ring ring.
No, it should be the other cam. That's the...
Oh, it's right, but it's the wrong way around. You're connecting to power rather than ground kind of thing.
Okay.
It's ringing when it shouldn't be ringing. And it's not ringing when it should be ringing.
No, which is the... yeah. I suspect it's that one there. Anyway, I managed to, because the ringing tone is, that's better. The ringing tone is the, you need something like about 75 volts, which is because if you ever experienced, you happen to be holding the telephone lines when somebody rang you.
A bit of an experience.
You sort of went because that's if you've ever been on the end of 2 bits of wire that are connected to the magneto to ring the line at the other end, it is pretty pulsy. At probably 90 or 100 volts at peak.
And volts were there all the time.
Oh, well, the 48 volts was there all the time,
yeah.
but the 48 volts was just DC. It was straight DC, and usually out of a battery, so it was really, really stable. But the ringtone, they went up to 75 volts and above that for the short periods of time to get the bell to ring, and it was AC, effectively AC that they were putting down the DC line. But anyway, that's the Ringer Dynamotor. The Ringer Dynamotor.
Who would have thought?
Well, who would have thought you've got an electromechanical device and it sits there 24/7 doing exactly that, just sitting there, providing all of the different tones that you need to run a telephone system. Just phenomenal. Anyway, so, and this is, as I mentioned when I brought it in the first time, the reason we're doing this is we are building a demonstrator electromechanical exchange. And so this will form obviously the ringer and the dial tone and the blah, 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 all the stuff, as well as the uni selectors. There'll be 4 lines, so there'll be 4 of those Decadic phones, and you'll be able to ring any of the other lines, and it will actually ring that line. Yep. You'll pick it up, you'll be able to talk to the people, put it down. If you've got everything, if all the lines are used, it'll come up with the can't get anything line tone. Somebody said to me, so if I dial 1194, I'll get the time then.
No.
And I went, well, that's an interesting rabbit hole to go down. But
this is a PABX rather than an exchange.
Correct.
Yep.
Correct. It is a personal exchange. So yeah. Anyway, so that's a Ringer Dynamotor. Now, Is it possible it's running backwards? Comms is negative. Yeah, no, it is. It is. The negative is actually the positive.
Yeah, so positive is ground.
Positive is ground.
Yeah.
In this particular case, and that's
Yeah,
the way.
In any exchange,
Yeah.
positive was ground.
Yeah. And so that was it's when you measured the voltage on the line, it was always minus 48 volts. So no, it is around the right way. I just haven't got the right cam, Darren. I haven't found.
It's definitely inverted.
So and short of me sitting there with a multimeter and keying out every line and trying to work it out, which I'm going to have to do when we install it. But for demonstration purposes,
You want the ring to be right.
you want the ring to be right. Now, talking about the ring being right, have I got a deal for you?
Oh, here we go.
Now, I'll stop that rotating.
Yeah, you don't want to wear it out.
No, I don't want it rotating. Now,
What do we got there? This is even older.
no. This is actually younger. But just let me plug it in.
Or a month or two, yeah.
Just let me.
Oh, what's he going to unplug? Look out.
Yeah, what am I going to unplug? That's a bit of a dangerous.
Are we still on here?
Now, I won't bang it on the desk because if I bang it on the desk, you'll
know about it.
you'll know everybody will know about it. Now, I'll give you those, Steve. Now, what I've put on the desk is a surprise, a black box. But I worked in a theatre in Adelaide called the Adelaide Repertory Theatre, and we needed our phone ringing circuit. Our phone ringing circuit was effectively one of these old telephone switches and a 48 volt power supply, and you manually rang the phone on stage.
Yep.
That was, and I went, oh, have I got a deal for you? Because at the time I was trying to trying all sorts of electronic bits and pieces. So I built them a telephone ringer box. Two lines, and there were two outputs that come out here. These are the old. Now, that's actually illegal because you can. That's a 240 volt plug originally.
That's 110 volt plug.
That's 110 volts.
Yep. American. Yep.
Or American 120 volts. Yes. So it wasn't even a T connector, but anyway, I built up a little circuit. It uses two 555s.
Yep.
So one which creates the ring, one which creates the frequency of the ring, one that creates the style of ring, one that creates the frequency of the ring, and then I had it switched on to two lines, so you could have two. We had plays where there were two phones, and people were playing phones off. The ring frequency you could set here. It was just, and this was part of the R in the RC for the 555.
Yep.
So 26 hertz down to 0.3 hertz, and then there was a UK Australian style of ring, and then there was the US style of ring. So depended on the play. So if I've got it on the UK style, and it just rang away, and you can see here you had some sort of indication that there was something going out to the stage, because in most cases you couldn't see the stage. Now, if I went to the US, long ring, long ring. Now, so you could change the frequency.
Subtle difference, yeah.
And you get to a point where it's not even triggering the... So 17 was where we used to have it. Then if I change back to UK... So that was 2555s. There is it's a couple of relays in here, and there is I think it's about a 45 volt power supply that I built in here. So just enough to get the bells in the in a standard telephone to actually ring. But anyway, that was a bit of fun that I built up a fair while ago. JC Enterprises was my so yeah, that was Adelaide Repertory Theatre for a little while. That was their ringer unit that they used to use for and 2555s, and it is switching the relays.
Yeah.
So the relays are the thing that is doing the 40 volt changes. Mm-hmm. That's why you hear a bit of hysteresis on the relays when you go to the higher frequencies, because the relays are struggling to keep up with it. Oh, okay. So yeah. But anyway, so that's that's the electronic version of the electromechanical down on the floor of the studio. Now, how are we going for time?
No doubt you're over.
No, I've got 10 minutes. I'm just do we? No, I might leave that until next time. I'm gonna finish early today. And confound everybody instead of going an hour and 20 minutes, which is what we usually do. Now, no, this will probably take 10 minutes. This is about Steve.
Oh no.
Spaceweather.com. Now, anyone who follows Space Weather, there is a phenomenal thing that's going on right at the moment. Space Weather has, over the last few days, they have been, unfortunately, in the northern hemisphere, because they don't have that much cloud cover, but they have some pretty impressive auroras that are happening, and it's not because of a solar storm.
Yeah.
It's because of coupling between the magnetic field of the sun and the magnetic field of the Earth.
Does this upset propagation in the same way an aurora does?
I think it does, well and truly, because
propagation hasn't been that great.
The same warnings are coming out.
Yeah.
But so there's some phenomenal, and they call it the. Where is it?
Strong something or other.
No, oh, sorry,
yeah,
that was me.
far.
That was too far. Oh no, that's the effect. That's that effect.
Yeah.
I'll go into that in a sec. Where is it? It must be, no, let me go back a page to the 30th and view that. Yes, this is the one I want. So we are talking about the Russell-Mc-Pherron effect. So the storm is subsiding, but it's not over. The Russell-Mc-Pherron effect is still active, linking the magnetic fields of the sun and the Earth to produce an ongoing G1, G2 geomagnetic storm. They still refer to it as a storm. Yeah. High latitude auroras, etc., etc. But the interesting one that was posted today is that fantastic shot. Yeah. Which is called Steve. So I've got Steve right next to me. And Steve stands for the Strong Thermal Emission Velocity Enhancement. Now, we had a bit of a joke about that earlier, but so absolutely phenomenal. And the thing about this picture is they talk about the cross. So the Milky Way goes in one direction and this effect goes in the other direction.
Is that in both hemispheres like that, or?
I don't know. I assume it's the direct. This just happened to be coincidental in the direction of the particular effect. But
well, I know these Steves are just like a long beam. But whether or not they're vertical or they're at another angle to the Earth, I don't know.
I think that's a question for Dr. Andrew Kleckerchuk.
Yeah, right.
So Andrew, if you're out there, please let us know. No. Oh no, that's the.
Yep.
That's actually we'll go back because they reposted this picture because it's a phenomenal picture.
Yeah.
Oh. Yeah.
But it's a very strong, very, very strong beam.
Oh, well and truly.
Unlike the normal beams that you get in an aurora.
Oh, that are moving and all sorts of stuff.
Well, you can get for one aurora I saw back in 2016 had a beam that literally went as high as you could go.
Okay.
And but it was just one beam.
Okay.
But it wasn't that. It was definitely a beam, and it was only there briefly.
But absolutely phenomenal.
Yeah.
This is off the show. Absolutely off the show. Interesting kit anyway. Okay, all the hassles people had when swapping to fibre to the node if they had an original extension bell. You are spot on, Colin. Oh dear. Steve, sponsored by SpaceX. Oh, there you go. Thank you, Colin. So there has been space weather caused by Steve and a few other bits and pieces, the Russell-Mc-Pherron effect. So our conditions are interesting. I have to say that there are certain bands that have absolutely go off during these effects, and there are bands that are absolutely clobbered by these effects.
And it depends on your latitude.
Oh, correct.
And of course, where we are at -42, or worse,
Correct.
We tend to get clobbered.
Yeah. And lower down, so 630 metres and 2200 metres, forget it.
Yeah.
The total electron content in the atmosphere right at the moment is off the show. And it's where the equator is, there are really, really strong clouds of electrons that are just absorbing everything.
Which is funny because most bands at the moment are fairly active, but not all the time.
No. So there is space weather. Now, very quickly, future training. We do have a foundation training and assessment day on the 25th of October. So if you're interested, and we've had a few people come along tonight and pick up foundation license manuals, so hope to see them at the day on the 25th. And then there is a standard, advanced and regulations assessment day, which is the last one for the year, on the 29th of November. And a reminder, next week. So next week is our All-Star Forum night. So if you don't know what All-Star is, or if you do know what All-Star is, please come along and share it. But All-Star, the forum next week is on All-Star and will be streamed as well. November the 5th, which is our presentation night in November, we have Phil Tyson coming along from the Sound Preservation Association of Tasmania.
Yep.
He's doing a fantastic presentation on Australian broadcast radio, so perspectives of Australian broadcast radio. And he has some fantastic recordings going way back in history. Now, unfortunately, that won't be streamed. He's actually asked for it not to be streamed, so you're going to have to be, unfortunately for our streaming viewers, you're going to have to be up here and in the club rooms to actually see that particular presentation. So apologies about that. And then on the second Wednesday night, which is November the 12th, we've got an EMR safety quiz night.
Oh, okay.
So we'll have a safety quiz. We're going to have prizes. You can be online for that. We've got a bit of a quiz on what you learnt from your EMR assessments.
Oh, better get it done then, eh?
Yeah.
I've got at least 6 antennas.
There's your impetus for doing your assessments, and then coming along and answering questions. Do you know what the 6 minutes, why it's 6 minutes exposure. Do you know, Steve? Do you know?
I haven't read the documentation yet. But
No. It's easy.
But it's got something to do with the average person.
Correct. It's average exposure that does not cause heating effect or a health effect.
Yeah.
So that's a physiological limit that they've put on it, and that's what's incorporated into the standard. So that's where the 6 minutes comes from. So yeah. Anyway, all right. Now, just a quick check. No, you're still sponsored by SpaceX, Steve.
All right.
So that's your blooming lot for this week. Thank you for being on the stream or watching or etc. This is the VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our Wednesday experimenters groups. And thank you for coming along, Steve.
Thank you.
73.
Cheerio.